Hello and welcome to Mechlen 360. In this video, I want to solve a problem with you to illustrate the parallelogram law of vector addition as well as the concept of the minimum force. Alright, so let's read the question together. Two tugboats are pulling a barge. Alright, so this is the two tugboats they are talking about, and that is the barge. So if the resultant of the forces exerted by the two tugboats is a 5,000 force directed along the axis of the barge, 5,000 pounds. The question is, so A, we are to determine the tension in each rope. So find the tension in this rope. That tension will actually move away. Let's call this T1. And then the tension here, let's call it T2. And then given that alpha is 45, so this alpha here is 45. All right, let me try to draw it well. So I have a point here, which I am calling point B, which is this point B here. Now I have a tugboat, and then the tension in this one is, let's say, T1. All right, then I have another tension here, which I'm calling, say, T2. All right, now we are told that the magnitude of the resultant forces is actually horizontal, and it is in this direction, and it's given by 5,000 pounds. Our task is to find the tension in T1 and then the tension in T2. Since we are using parallelogram, we are just going to connect the two tensions to the horizontal, since that is the diagonal, in other words, the resultant. So I'll stand here and connect this to this. And this is actually going to be parallel to T1. Then I'll connect this point right here to this point. And that is also going to be parallel to T2. All right. Now this angle right here is 30. And this is alpha, but we are told that it's 45. Okay. So now applying alternate angles or Z angles, I can say that this angle here should be equal to this angle here. It means that this angle will be 45 and this angle is going to be 30 right here. Okay, now after here, what we do is that we are going to apply the sine rule. But then what is the angle here? So angle in a straight line, angle in a triangle add up to 180. So let's pick our calculators right here. So then I can say that if I have 180 minus 30 plus 45, and what am I going to get? But I'm going to get 105. So this angle right here is 105. Okay. So after getting this point, we are going to now apply the sine rule. So let's use the sine rule. So using the sine rule, I can actually say that this side, which is T1, is opposite 45. So I can write that T1 all divided by sine 45 is actually equal to T2, and T2 is opposite to this side, which is the 30. So T2 divided by sine 30, let me do it well, divided by sine 30 should be equal to this 5,000 is opposite to 105. So I can say that 5,000 all divided by sine 105. All right. So after writing this, then I can say that, okay, if I want T1, it's just going to be 5,000 divided by sine 105. Then I'll multiply it by sine 45. By doing this, I can get T1. And what is that? T1 is going to be simply, T1 is going to be 5,000. So 5,000 divided by sine 105, and I'll multiply it by sine 45. So multiply by sine 45. All right. So I'm going to get 3660.254. 3660.254 pounds. So that is the tension T1. How about T2? So T2 is going to be the same thing, but I will just change the angle. And this time around, I'm going to do sine 30 instead of 45. So I'll pick my calculator again. Oh, I can even use what I have already. I will just change this one to sine 30, and that's all. So sine 30, and what is that? So I'm going to get 2588.190. 2588.190 pounds. So that is T1 and T2. So the first part of the problem has been solved. Okay, so the first part of the problem has been solved. Now let's look at the second part. He said that the minimum, so the value of A for which the tension in group 2 is minimum. Let's look at that part. All right, let's look at that part. So I will draw it again. But this time around, this is how it's going to look like. T1 will be here, and then I have the resultant, which is 5,000 here, 5,000 pounds, and then I have the T2 here. So I will just join this side to this side, and then I will join this side to this side. I didn't draw the parallelogram well. Okay, so I will join this side, yeah, something like this. So T1 is here, and then T2 is also here. Now take notice that this is still 30 degrees, but this time around this is alpha. So using alternate angles again, I will write this. But the question is, this time around this is alpha, so here is no more 105. So let's say the angle here is beta. All right, now this is what the question is saying. We should calculate the minimum force. Look at it again. Calculate the minimum force, the minimum tension in group 2, all right, and the value of alpha at which this occurs. All right, so I know 30, I have T2 here, I have 5,000, I have beta here. So if I want to use the sine rule, so using the sine rule, I have two sides, so I can use those two sides, and then it's going to be, so I can say that sine 30 divided by T2 should be equal to sine beta divided by 5,000. All right. After this part, I can say that T2 sine beta is equal to 5,000 sine 30. All right. Now at this point, the question is, what is T2? That's what they want, the minimum value of T2. But T2, 5,000 sine 30 is going to be, so let's see, 5,000 sine 30. So 5,000 sine 30 is nothing but, that is, I think it's going to be 2,000, yeah, 2,500. That is the minimum. That's the, sine 30 is half of 5,000 divided by sine beta. All right. So the question is, if I want the minimum force, then the minimum force is going to be the function of sine beta. But the maximum value of this sine beta is actually 1, which occurs at beta equals 90 degrees. In other words, what we are trying to say is that whenever I divide 1 over maximum, I'm going to get minimum. It means that the minimum force is actually going to be 1 over the maximum. In other words, the minimum force will occur. So the minimum force T min will occur when I have sine beta to be actually 1, so that the 1 over the maximum will give me the minimum. And so in fact, the minimum force is actually 2,500 pounds. All right, so that's how we solve problems like such. Now he said we should find the minimum force, and then we should also find alpha. So this time around, this is what we have. So T2 minimum is this one. All right, let's solve for the angles. Now we just said that beta is 90. This is very interesting because if beta is 90, then it means that this angle right here means these two forces are actually perpendicular to each other. In other words, for T2 to be minimum, then it means it has to be perpendicular to T1. In that case, if I want alpha, then alpha is going to be alpha plus 30 plus 90 equals 180, from which I can say that alpha is actually going to be 180 minus 120, which is 60. Okay, so the angle alpha is actually 60, and then the minimum force in the minimum tension is 2,500 pounds. Thank you very much for watching.